The first question, so NEET 2019 is asked this one. The stress strain curves are drawn to different materials X and Y. So it is observed that the ultimate strength point and the fracture point are close to each other in the material X. So in the material X, the ultimate strength and that is the ultimate strength and so fracture point, so both are seen very close to each other. Then in the point of Y, but far apart, so this is a far apart in the material of Y. The question is asked, so X and Y materials, X ಮತ್ತು Y ಯಾವ ಮೆಟೀರಿಯಲ್, ಅಲ್ಟಿಮೇಟ್ ಸ್ಟ್ರೆಂತ್ ಫ್ರಾಕ್ಚರ್ ಕ್ಲೋಸ್ ಇದಾವೆ, ಇದರಲ್ಲಿ X ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ Y ಅಲ್ಲಿ ಅಪಾರ್ಟ್ ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ ಯಾವ ಮೆಟೀರಿಯಲ್, ಯು ಹ್ಯಾವ್ 4 ಆಪ್ಷನ್ ವಿತ್ ಯು. ಅಂದ್ರೆ X ಅಂತಕ್ಕಂಥದ್ದು ಯಾವುದು, ಸೊ ದೆನ್ Y ಅಂತಕ್ಕಂಥದ್ದು ಯಾವುದು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಕ್ವಶನ್. ಓಕೆ, ಸೊ ಲೆಟ್ಸ್ ಸಿ ದಿ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಹಾಗಾದ್ರೆ ದೆನ್ ಕಮ್ ಟು ದ ಪಾಯಿಂಟ್ ಆಫ್ ಗ್ರಾಫ್. ಓಕೆ, ಲೆಟ್ಸ್ ಸಿ ದ ಸೊಲ್ಯೂಷನ್. ನೋಡೋಣ, ಗ್ರಾಫ್ ಅನ್ನ ನೋಡೋಣ. ಇಲ್ಲಿ ನೋಡಿ, ದಿಸ್ ಇಸ್ ದ ಗ್ರಾಫ್. Okay, stress and strain curve graph. This is called as a ultimate strength. This is called as a fracture. Okay, so fracture point and ultimate strength, if they are close, so close idavappa andre nodi, so those materials are called as enta materials anta karitivi. So those materials are called as so brittles. For example, so brittles materials ge enen examples anna kodbodaappa andre nodi, glass so bega ಹೊಡೆದೋಗುತ್ತೆ. Then wood. Okay, so these are the examples for what brittle materials. So if they are apart idavappa andre, so if they are apart, so those materials are called as avake ಏನಂತ ಕರಿತೀವಿ, that is called as what, so that is a ductiles. Okay, so ಬೇಗ ಏನಾಗಲ್ಲ ಇವು, so it will be what, extension ಆಗಿ ಕಟ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ. So for examples ಏನೇನು ಕೊಡಬಹುದು ಇದಕ್ಕೆ, copper, gold, okay, so aluminum. So these are the materials are called as what, ductiles. So hadre look at the option which is the right answer. Let's see. Nodi, X antakantaddu close ide andre, so close ide andre yava materials barutte illi, so those materials are called as what, brittles. So apart ide andre Y antakantaddu enagutte illi, so ductiles. So which is the option is right? Ready? So first one is brittles and ductiles, that is a option B is the right answer for the question number first. Okay, so let's come to the point of second question. Okay, nodi, second question anna nodi. So this is NEET 2020 ನಲ್ಲಿ ಕೇಳಿರ್ತಕ್ಕಂಥದ್ದು ಇದು. ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ಏನ್ ಕೇಳಿದಾನ ನೋಡಿ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಇಲ್ಲಿ. The problem is like that: a wire of length L, area of cross section A. Okay, this is the wire. Okay, so E wire indu, so this is called as a length is L and area of cross section is A, is hanging from fixed support. Okay, this is a fixed support is hanging. The length of the wire is changes L1. Okay, so length of the wire anna you have to changes L1. Mass suspended, so mass suspended andre it will be elongated, extended. So the length is changes. Okay, nodi, its length change agutte, its length change agutte. How much? It is a L1 length is change. Okay, that is a, the length of the wire is changes to the L1 when the mass M is suspended, it's to the free end. Okay, so M mass is suspended to the this one. Expression for Young's modulus. So Young's modulus expression ಏನು ಅಂತ ಕೇಳಿದಾನೆ. Okay, ಹಾಗಾದ್ರೆ let's see the solution for the problem. Today we know that Young's modulus, so Young's modulus is equal to stress, okay, divided by strain, that is called as change in the configuration divided by original configuration. So that is a FL divided by A into what? Delta L. So now what is the change in the length? Let's see how much change in the length. So the change in the length is equal to enagate nodi. So look at this one. So the change in the length is equal to, okay, first ge nodi, the length changes to, okay, ಎಷ್ಟು length changes ಆಗುತ್ತಪ್ಪ ಅಂದ್ರೆ, so that will be changes to L1 ಅಂದ್ರೆ L1 minus L, that is the change in the length. So now you have to put the value nodi F. So force up andre that is called as M mass, that is equal to ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ M into G. So L is as it is, then A. So what is the change in the length? That is a L1 minus L. So that is a new Young's modulus is equal to, what is the answer? So MGL divided by A into L1 minus L. This is a change in the length. So which option is correct for this answer? Okay, what is the correct answer? MGL. So L1 minus L, that is a option D is the correct answer for the second question. So let's come to the question number 3. So okay, question number 3 is,
hey there, subscribe to my channel and also press this bell icon so you can get latest video notification.
Ready? NEET 2019 ನಲ್ಲಿ ಕೇಳಿರ್ತಕ್ಕಂಥ ಕ್ವೆಶ್ಚನ್, when a block mass m is suspended by the long wire of length is L, the length of the wire becomes L plus L. Ready? So this is called as a wire. Okay, so this is a wire. So this wire into it is suspended with the mass is m. Okay, by the long wire, length is how much? L. So the length of the wire becomes, ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾನೆ, the length of the wire becomes L plus L. So then elastic potential energy stored by the extended wire. What is a potential energy? Okay, so elastic potential energy is how much? Okay, ಹಾಗಾದ್ರೆ ಇದು ಪ್ರಾಬ್ಲಮ್, ಕೇಳಿರ್ತಕ್ಕಂಥ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ನೋಡಿ, ಈಗ ಲೆಟ್ಸ್ ಸಿ ದ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಸೊ ಸೊಲ್ಯೂಷನ್ ಅನ್ನ ನೋಡೋಣ ಈಗ. ಸೊ ಫಸ್ಟ್ ಒನ್, ದಟ್ ಈಸ್ ಎ elastic potential energy. Okay, so that is in elastic potential energy. So elastic potential energy per unit volume. Okay, so per unit volume formula. So per unit volume formula, that is equal to ಏನಿದೆ? So that is a half into stress into strain. Okay, so this is a formula. So ಅಥವಾ elastic potential energy is equal to half into stress into strain into volume. Okay, so this is a formula for elastic potential energy. So now you have to put the value, that is U is equal to 1 by 2. So stress is equal to force andre eshtagutte illi? Force is equal to M into G. So that is mg divided by area. So into strain andre, so strain means change in the dimensions. Nodi, change in dimensions delta L, change in dimensions is equal to final ಎಷ್ಟೈತಿ ಇಲ್ಲಿ L plus L minus initial ಎಷ್ಟಿದೆ L. The change in the dimensions is equal to ಎಷ್ಟು ಬಂತು ನೋಡಿ, cancel ಆಗಿ small l. So that becomes small l divided by original capital L into volume. Volume ಅಂದ್ರೆ area into what? Length. So now area cancel, length cancel. So we get the answer is 1 by 2 mg small l. So this is the answer for the question. So 1 by 2 mg l. So this is option A is the right answer for the third question. So let's move to the fourth question. Nodi 2018 ಅಲ್ಲಿ so ಕೇಳಿರ್ತಕ್ಕಂತ ಪ್ರಾಬ್ಲಮ್ ಇದು. ನೋಡಿ ಈಗ 2 wires are made up of the same material. This is very important. Same material ಅಂದ್ರೆ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಏನಿದೆ ಅಂತ ಅರ್ಥ ಇಲ್ಲಿ ಸೇಮ್. and have a same volume ಕೂಡ ಸೇಮ್ ಇದೆ. The first wire, okay, ನೋಡೋಣ ಈಗ first wire cross sectional area, okay, ಇದು first wire ಇನ cross sectional area ಎಷ್ಟಿದೆ ಇಲ್ಲಿ A is the cross sectional area and the second wire, okay, so this is the first wire, okay, then come to the point of second wire, its area of cross section, okay, its area of cross section. So idrada area of cross section ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳ್ತಾನೆ ಇಲ್ಲಿ 3a. if the length of the first wire is increases by delta L, okay, so first wire ನ length ಅನ್ನ delta L ಅಷ್ಟು increases ಮಾಡಿದಾನೆ by applying the what force, okay, how much force is needed to stretch for the second wire by the same amount ಅಂದ್ರೆ so ಇಲ್ಲಿ ಕೂಡ delta L ಅಷ್ಟು increases ಮಾಡೋದಕ್ಕೆ, okay, so how much force is needed, so ಎಷ್ಟು ಫೋರ್ಸ್ ಬೇಕಾಗುತ್ತೆ ಅಂತ ಕೇಳಿದಾನೆ. ಸೊ ಹಾಗಾದ್ರೆ both are elongation are same ಅಂದ್ರೆ first wire ನ elongation is equal to second wire ನ elongation, ಎರಡು ಸೇಮ್ ಇರುತ್ತೆ ಅಂತ ಅವನೇ ಹೇಳಿದಾನೆ ನೋಡಿ ಇಲ್ಲಿ. So how much force is needed to stretch the second wire by the same amount, okay, so ಇಲ್ಲಿ ಎಷ್ಟಿದೆನೋ ಅಲ್ಲಿ ಅಷ್ಟೇ ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಆಗಬೇಕೀಗ, okay, so this is the problem. ಸೊ ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಇನ್ನೊಂದು ಕೊಟ್ಟಿದ್ದಾನೆ ಸೇಮ್ ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಇದೆ, okay, ಹಾಗಾದ್ರೆ ವಾಲ್ಯೂಮ್ ಅಂದ್ರೆ ಸೊ ಏರಿಯಾ ಇಂಟು ಲೆಂತ್, okay, ಸೊ ನೋಡಿ ದಿಸ್ ಈಸ್ ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ A ಆಯ್ತು ಅಂದ್ರೆ so you have to take the length, okay, so length is equal to ನೋಡಿ, so length is equal to ಇಲ್ಲಿ area into length is L ತಗೊಳ್ಳೋಣ, okay, ನೋಡಿ ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಬರಬೇಕು, ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಅಂದ್ರೆ ಏರಿಯಾ ಇಂಟು ಲೆಂತ್ ಬಂತು, okay, ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ L/3, ಇದ್ರದ್ದು ಲೆಂತ್ L/3, okay, so L/3 ನೋಡಿ, so L/3 ಅಲ್ಲ, ಲೆಟ್ಸ್ ಸಿ, okay, so ನೋಡಿ ಈಗ ಲೆಟ್ಸ್ ಸಿ ದ ಸೊಲ್ಯೂಷನ್. ಲೆಟ್ಸ್ ಸಿ ದ ಸೊಲ್ಯೂಷನ್ ನೋಡಿ, ಸೊ ದಟ್ ಈಸ್ ಇಲ್ಲಿ ಏರಿಯಾ A ಆದ್ರೆ ಇಂಟು ಲೆಂತ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 3al ಬಂತು, ಇಲ್ಲಿ ಲೆಂತ್ ಏನಾಗುತ್ತೆ ಇದು L, 3al, ವಾಲ್ಯೂಮ್ ಏನಾಯ್ತು ಇಲ್ಲಿ ಸೇಮ್ ಆಯ್ತು, ವಾಲ್ಯೂಮ್ ದೀಸ್ ಟು, ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ಈಗ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಸೇಮ್ ಅಂತ ಆಗಿದೆ, ಓಕೆ, ಸೊ ಲೆಟ್ಸ್ ಸಿ ದ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದ ಪ್ರಾಬ್ಲಮ್. ಹಾಗಾದ್ರೆ ನೋಡಿ ವಿ ನೋ ದಟ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್, ಓಕೆ, ಸೊ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಿದೆ ಫಾರ್ಮುಲಾ, ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು FL divided by A into delta L, ಓಕೆ, ಸೊ ಎರಡು ವೈರ್ದು ಸೇಮ್ ಇದೆ ಎಕ್ಸ್ಟೆನ್ಷನ್, ಓಕೆ, ಸೊ ಎರಡು ವೈರ್ದು ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ ಸೊ ದಟ್ ಬಿಕಮ್ಸ್ ಡೆಲ್ಟಾ L ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗುತ್ತೆ ನೋಡಿ, ಡೆಲ್ಟಾ L ಇಸ್ ಈಕ್ವಲ್ ಟು FL A ಇಂಟು ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್, ಓಕೆ, ಹಾಗಾದ್ರೆ ಫಸ್ಟ್ನೇ ವೈರ್ ಇಂದು ಫೋರ್ಸ್, ದೆನ್ ಲೆಂತ್ ಈಸ್ ಹೌ ಮಚ್ 3l, okay, so 3l, area of cross section is A into Young's modulus Y, second wire into force F dash into length is how much L, divided by area of cross section is 3a into Young's modulus y is the same. So now y get cancel, L get cancel, A cancel. So 3 3s are 9. So that is F dash is equal to, what is the answer? 9F. Okay, so which is the right answer? That is option A is the right answer for the fourth question. This problem is asked in 2018. Okay, so let's come to the point of fifth question. Okay, ನೋಡಿ NEET 2017 ಅಲ್ಲಿ ಕೇಳಿರ್ತಕ್ಕಂಥ ಪ್ರಾಬ್ಲಮ್ ಇದು. ಓಕೆ, ಸೊ 17 ಅಲ್ಲಿ ಕೇಳಿದಾನೆ. ನೋಡಿ ಏನು ಕೇಳಿದಾನೆ? ದಿ ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ದ ಸ್ಪೆರಿಕಲ್ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ B if it is subjected to uniform pressure P, the fractional decreases in the radius ಅಂತ ಕೇಳಿದಾನೆ. ಹಾಗಾದ್ರೆ so we know that is a bulk modulus is equal to minus P divided by delta V by ಏನಿದೆ ಇಲ್ಲಿ V. So now you have to simplify minus P into V divided by delta V. Okay, so ಹಾಗಾದ್ರೆ you have to ನೋಡಿ ಈಗ ಇಲ್ಲಿ V divided by delta V ಪ್ಲೇಸ್ ಅಲ್ಲಿ. ಓಕೆ, ಸೊ you have to ಪ್ರೆಸರ್ಗೆ ನಾವು ನೋಡೋಣ ಚೇಂಜ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಫ್ರಾಕ್ಷನಲ್ ರೇಡಿಯಸ್ ಅಂತಕ್ಕಂಥದ್ದನ್ನು ಮಾಡಬೇಕಾಗಿದೆ. ಸೊ ಹಾಗಾದ್ರೆ ರೇಡಿಯಸ್ಸಿಗೆ ಮಾಡಬೇಕಂದ್ರೆ V divided by delta V is equal to, so V divided by delta V ವಾಲ್ಯೂಮ್. ನೋಡಿ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ವಾಲ್ಯೂಮ್ is equal to 4/3 pi r cube. ಓಕೆ, ಸೊ ಡೆಲ್ಟಾ ವಿ ನೋಡಿ, ಡೆಲ್ಟಾ ವಿ ಅನ್ನ ಹೆಂಗೆ ಕಂಡುಹಿಡಿಬೇಕು? ಡೆಲ್ಟಾ ವಿ is equal to ಏನಾಗುತ್ತೆ, 4/3 pi is as it is, r cube ಇದ್ದಿದ್ದು ಏನಾಗುತ್ತೆ 3r ಸ್ಕ್ವೇರ್. ಓಕೆ, ಸೊ ಅಂದ್ರೆ 3 ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಸೊ ಎಷ್ಟು ಬರುತ್ತೆ ಇಲ್ಲಿ, ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 4 pi r ಸ್ಕ್ವೇರ್. ದೆನ್ 4 ಕ್ಯಾನ್ಸಲ್, pi ಕ್ಯಾನ್ಸಲ್. ಸೊ ಎಷ್ಟು ಉಳಿತೈತಿ ಇಲ್ಲಿ r. ಓಕೆ, r divided by 3. So r divided by 3, that is a delta r. Into what? Into delta r. Okay, so ಹಾಗಾದ್ರೆ into ಏನು ಬರುತ್ತೆ ಇಲ್ಲಿ delta r divided by 3 into delta r. So now put this value, that is a bulk modulus is equal to minus P into, so V divided by delta V. So V divided by delta V means what? R divided by, so 3 into what? Delta R. Okay, R. So hagadre ನೋಡಿ, look at this one, which is the so right answer for this question. ನೋಡಿ, the bulk modulus of the spherical object is B if the subjected to uniform pressure P. Okay, P, the fractional decreases in the radius. Okay, so ಎಷ್ಟು decreases ಆಗುತ್ತೆ, so we have to, that is a delta R by R is equal to, so delta R by R is equal to, so delta R ಅಲ್ಲಿ ಏನಿದೆ ಇಲ್ಲಿ, so delta R place ಅಲ್ಲಿ ಏನಿದೆ 3B. Okay, so R place ಅಲ್ಲಿ ಏನಿದೆ ಇಲ್ಲಿ P, so decreases. Okay, ನೋಡಿ, decreases, minus sign, with minus sign. So that is P divided by 3B. So P divided by 3B, which is the right answer for this question. That is a third option. So minus ಏನು ಮಾಡುತ್ತೆ ಇಲ್ಲಿ, decreases ಅನ್ನು ತೋರಿಸುತ್ತೆ. So that is a option C is the right answer for the fifth question. According to Hooke's law of elasticity, if stress is increased, the ratio of stress to the strain. So let's see the solution. We know Hooke's law. So what is the Hooke's law statement? So that is, Hooke's law is states that within elastic limit, stress is directly proportionality to the strain. Okay, so stress is directly proportionality to the strain. So now we have to remove proportionality sign. Stress is equal to K into strain. So what is K is here? K is called as modulus of elasticity. K is called as modulus of elasticity. So this modulus of elasticity depends on the factor. So which factor? It depends on the nature of the material. Nature of the material. So now if the stress is increased, the ratio of stress to the strain. The ratio of stress to the strain is what happened? Let's see. This is a stress divided by strain. So that is equal to what? K, where K is called as modulus of elasticity, that is a constant. So now the answer for this question remains constant, that is a option D is the right answer. Okay, let's go to the 7th question. Identical springs of steel and copper. So that is Young's modulus of the steel is greater than to the Young's modulus of the copper, are equally stretched. Okay, so both are equally stretched. So this is a steel is here, this is a copper, both are equally stressed. So that means delta L is equal to same, that is this delta L. Now L. The question is, less work is done by the copper spring, less work done by the steel spring. Now you have to work done. What is work done is here? Work done is equal to, so 1 by 2 into F into delta L. Okay, so this is a equation. So work done is equal to F into delta L. So now what is delta L is here? You know that Young's modulus is equal to stress divided by strain. Stress by strain, that is equal to FL A delta L. So now FL divided by A delta L is here. Now delta L is equal to, because both are what? Same. It is a stretched. Both are same stretched means this delta L is equal to this delta L. So delta L is equal to FL divided by A into Young's modulus. Okay, so now from this equation what you have to conclusion is here, the delta L is inversely proportionality to the Young's modulus. Okay, so Young's modulus. So we know this is the equation is here, delta L is inversely proportionality to the 1 by y. So from this equation number 1, this is equation number 2. So from the equation number 1, so work done is proportionality to the delta L. Okay, work done is proportionality to the delta L. So this is proportionality to the Young's modulus. So now which is Young's modulus is more? Okay, so the Young's modulus, which one is more? That is Young's modulus of the steel is more than Young's modulus of copper. This is given is here. Now work done and Young's modulus both are inversely proportionality. That is a Young's modulus of the steel. Work done. So that is the work done of the steel. Work done of the steel and work done of the copper. So that means this is a work done of the steel is less than the work done of the copper. So that is a answer for this question is. So answer for this question is work done for the copper is more. Okay, less work done in copper. No, less work done in steel. So look at this one, less work done in the steel. That is a option B is the right answer for this question. Go to the next question, question number 8. So which of the following relation is true? So now this is a one given hints to how to remembering for the equation. So that is, what is the relation is true? That is Young's modulus and 2 eta and another one is 1 minute. Okay. So this is the Young's modulus. So this is Young's modulus, this is eta and this is a k. So now how to remembering for this complicated equation? Very simple method. That is a first you have to equalization. Then 1 Young's modulus, it is in the bracket. Then 2 eta bracket, then that is equal to 3k bracket, then 1 minus, minus 1 plus, start with minus plus, then again minus. So then you have to put sigma, sigma, sigma. Then it is multiplication with 0, this is multiplication with 1, then this is multiplication with 2. Okay, now that is 1y, that means 1y means is equal to 2 eta 1 plus sigma is equal to 3k 1 minus 2 sigma. So that means there are two equations, I got it here. Young's modulus is equal to 2 eta 1 plus sigma. This is a one equation. Then y is equal to 3k 1 minus 2 sigma. So this is the second equation. Okay, so this is the relationship between Young's modulus and eta and sigma. So now which is the answer? So that is a familiar to this one is 2 eta 1 plus sigma. So that is option D is the right answer for the 8th question. So now shall I move to the next question, that is question number 9. Okay, so let's see the question number 9 is, for an elastic stretched wire, the ratio of its elastic potential energy and energy density of the wire is equal to. So let's see the solution. For elastic stretched wire, okay, the ratio of elastic potential energy. The elastic potential energy is equal to 1 by 2 F into delta L. So then, and energy density, that is energy density is equal to elastic potential energy divided by volume. So then that is equal to potential energy is how much? 1 by 2 F into delta L divided by volume. So now the question is energy, okay, potential energy per energy density. So that is volume. So now that is if ratio is how much? 1 by 2. Okay, force and energies are constant, that is volume. So now potential energy per energy density is equal to, what is the answer is here? That is a volume. So now the answer for this one is volume of the wire, that is a D is the answer. Okay, so now 10th one. Okay, so what is the 10th one? The bulk modulus of the incompressible liquid. Okay, that is a bulk modulus is B. The bulk modulus of the incompressible. Incompressible means the change in the volume is equal to how much? The change in the volume is equal to 0. So now let's see the solution. The bulk modulus is equal to minus P into delta V by V. Okay, that is equal to PV divided by delta V. It is minus is as it is. So that is bulk modulus is equal to minus. So what is a change in the volume? That is 0. So that means any number is divided with 0. Okay, 0. The answer for this one is infinity. So now that is a answer is C is the answer, infinity.